Everyone, so in this video I'm going to discuss major contributor, minor contributor, equal contributor, and resonance hybrid. I know that was a mouthful, but let's first begin with major contributor. What is that? So the major contributor is the most stable structure, and the reason that it's the most stable is because it's the least amount of energy. The minor contributor is in the least stable structure because it's the highest amount of energy, and the equivalent or the equal contributor is again equal. It's equivalent in energy. So I'll say that one more time. The major contributor is lowest in energy and therefore the most stable. Minor contributor, highest in energy, least stable. Equal contributor or equivalent contributor, they're equal in energy. Okay, so again, how do you determine if it's major or minor or equal? There are many rules, but I'm going to go over the main rules. So in this first example that you can see at the top, on the left, you have one you have a carbon cation or a carbon with a positive charge. On the right, you have no charges whatsoever. But if you take a closer look to the structure on the left, carbon is not fulfilling its octet. If you look to the structure on the right, all of them are fulfilling their octet. So because of that, the one on the right is going to be the major contributor. The one on the left is going to be the minor contributor. And the reason is because following the octet rule is the best. So that is rule number 1. Okay, rule number 2. So if you look in this next example, you can see that on the left structure, there is no formal charge whatsoever. If you don't know what formal charge is, go check out my video on that and come back to this one. The one on the right, you can see that oxygen has a negative charge and the carbon has a positive charge. So which one is going to be the major structure? Which one's going to be the minor structure? The major structure is going to be the one with no formal charge. So that is the second rule. No formal charge is better. Okay, and then the last rule that I'm going to go over is the following. In this next example, you have a carbon or a carbanion, a carbon with a negative charge or a carbanion, either or, how you want to call it. And the oxygen on the right, you can see has a negative charge. So which one is going to be the major contributor and which one is going to be the minor contributor? If you think back to the periodic table, you'll know that fluorine is the most electronegative element on the whole periodic table. Why is that important? Well, it's important because if you think about the electronegativity trend, oxygen is more electronegative than carbon, and carbon is more electropositive than oxygen. Oxygen being more electronegative allows it to hold that negative charge better. If we had a separate example and you had a carbon having the positive charge and an oxygen holding the positive charge in resonance, carbon with the positive charge would be better. Why? Because carbon is more electropositive. So in simple terms, the negative charge is better on the more electronegative element. The positive charge is better on the more electropositive element. So in this example, the negative charge would be better on the oxygen. Again, because oxygen is more electronegative. So now let's go over equal contributors and resonance hybrid.